Right, we have already seen what happens using our calculator with horizontal asymptotes, what they look like and what they stand for. What we're going to be looking at now is if we don't have our calculator, how can we find those horizontal asymptotes? So at the end of this video, you will be able to determine the end behavior of a function and find horizontal asymptotes. All right, in order to get us closer to that, let me just read this. It says, for numerically large values of x, we can sometimes model the end behavior of a complicated function by a simpler one that acts virtually in the same way. So you'll notice we have the function 3x to the fourth minus 2x cubed plus 3x squared minus 5x plus 6, and a second function, g of x equals 3x to the 4. I went ahead and graphed those, and if you want to graph those on your own, that's fine, or you just want to look at what I have, that's fine as well. Okay, so if you look at my calculator, Okay, so if you will look at my calculator, I have gone ahead and typed in both functions, and now I'm going to go ahead and graph them. And when I graph them, you can notice the functions do look different. However, what we're going to be looking at is what happens when x gets bigger and bigger and bigger, and as x gets smaller and smaller and smaller. So you can notice around 0 and 1, the functions do look quite a bit different. Their y values are different. However, they start running into each other. So as x gets larger, the functions are becoming closer together. And I'm going to examine the table to show you that. So notice when x equals 1, the two y values are different. When x equals 2, still different. But what's happening is they're getting closer in value to each other. And if I kept going, I'll just keep letting x get bigger and bigger and bigger. Hopefully you can see the y values, although they're off by 1,000, they're continually getting closer to each other. So what I wanted you to see from that is that even though those functions are two different functions, as x approaches infinity, the functions really start becoming the same function. And what happens with this one is pretty much this stuff, the stuff to the smaller power than the highest power, it becomes insignificant as x gets larger and as x approaches infinity. So 3x to the 4 would be an end behavior model for this big function, because as x gets larger, really only the highest power is what's controlling what is happening with the y values. So we're going to use that information to help us find end behavior as well as horizontal asymptotes. So let's look at some examples. First of all, we're going to find the end behavior model. We will then find the limit as x approaches infinity, and x approaches negative infinity, and then we will also find any horizontal asymptotes of the function. So we're going to do all those. So first of all, the end behavior model. What we're going to be doing is using what I had just talked about. When we're talking about end behavior, we're just going to look at the highest power of the problem. So if I look in the denominator, the highest power is the x to the fifth. So we really only care about the 2x to the fifth. And if I look in the denominator, I'm looking at what's happening in the denominator, and I really only care about the 3x squared because that's the one with the highest power. And we learned in the previous video about our properties that if I'm finding a limit, or looking at end behavior, we can divide the two limits. So since we have something in the top and something in the bottom, we are going to divide those. If I did that, I'd get 2/3 x to the third power, because we do subtract exponents. So that is an end behavior model. That's what's going to be happening with my function as x approaches infinity and negative infinity. So if I want to find the limit as x approaches infinity, what I want to be thinking of is as I put larger and larger and larger values in for x, what's happening with this function? And if I think x to a power, it's just going to keep getting bigger and bigger and bigger. So the limit as x approaches infinity, and when I multiply it by 2/3, it's still going to keep getting bigger, will be infinity. Okay, and then we're going to find the limit as x approaches negative infinity. And if I do that, if I'm approaching negative infinity, keep thinking we'll take a large number, a large negative number times a large negative number times a large negative number. That will give me, it will keep giving me an even larger negative number. So instead of approaching infinity on this one, our limit as x approaches negative infinity will be negative infinity. All right, so let's look at example 2. Again, if I'm looking at the end behavior, I really only care about the highest exponent, so I'm really only caring about the 2x to the third up top. and the 5x to the third down below. To get the end behavior model, we will divide those two, and we will simply just get 2/5. So that would be my end behavior model. And the next thing I want to do is find the limit as x approaches infinity. Well, we'll go back and do d on that part in just a second. Limit as x approaches infinity. There's no place to plug the x into, so no matter what, as I approach infinity, I'll just get 2/5 as an answer. And then for C, if we're finding the limit as x approaches negative infinity, again, there's no place to plug the x in, so we'll just always get 2/5 as an answer. Okay, so we found in a previous video, whatever the limit was, that's our horizontal asymptote. So for this one right here, both of these have a limit of 2/5, so my horizontal asymptote will be y equals 2/5. All right, going back to number 1, to find the horizontal asymptotes, there were actually, even though we have two answers, infinity and negative infinity are not finite answers, so there are no horizontal asymptotes in number 1. Okay, let's look at problem 3. If you'd like to try this one on your own, go for it. You can see how you do on it. All right, so again, if I'm examining end behavior, I'm looking at the highest power up top, and same thing down below. And my end behavior will be the division of those two, which will end up being 4 over 5x. So that's my end behavior model. If I'm trying to find the limit as x approaches infinity, as I continue to put bigger and bigger numbers in for x, the denominator is just going to keep getting bigger and bigger and bigger, but the numerator is always going to stay 4. So if I take 4 over a really, really big number and that number keeps getting bigger, my limit is going to approach 0. And then for C, if I find the limit as x approaches negative infinity, when I go to plug in a negative number that keeps getting larger and larger and larger, even though that's a negative number, it's going to become a very, very, very small negative number. So once again, my limit will approach 0. And then for part D, we're looking for horizontal asymptotes. So my limits were 0, so the horizontal asymptote will be y equals 0. All right, looking at number 4, this one is a little bit different. What we want to do on this one before we actually find the end behavior, on this one we won't find the end behavior model. We'll actually just be, well, let's see, we can go ahead and find the end behavior model. I don't know if that will help us. I think I'm just going to skip right to the limit. What we are going to be doing on this one is we're letting x equal the square root of x squared so we can compare. It's hard to tell what is going on with these if we don't have, if one of them's in a square root and one of them's not. So what we are going to do, since x is equal to the square root of x squared, what we are going to do right here is we're going to put the square root of x squared in for x, because basically you're squaring the number and you're square rooting the number, so it's no different. And then we'll put this up there. Okay, and then from here we can write this as one big fraction over x squared plus 1. And then still keeping in mind that we're comparing the degrees, I guess I could have called this a, we'll go ahead, we'll take x squared, and we'll take the x squared down here. X squared divided by x squared will just be 1. It is still under the square root, and the square root of 1 is 1. So my end behavior model is just 1. Right, this is where it's going to get a little bit tricky. When I find the limit as x approaches infinity, so as I am looking at 1, it's just always going to be 1. However, when I do the limit as x equals negative infinity, because we originally started with this problem, I do need to examine that. When I put negative infinity in, so if I put a bigger and bigger number in here, no matter what, this answer is going to be positive. And if I put a negative number up top, my answer will always be negative. So even though we do have a limit of 1, this one will actually be a limit of negative 1. Okay, so when we go to do D, our horizontal asymptotes, they are just our limits. So we've got horizontal asymptotes happening at 1, and we have a horizontal asymptote happening. Problem number 5, I'd like you to go ahead and pause this video and try this one on your own and then come back and see how you did. Alright, so on this one, we again are going to, if we would like to find the limit as x approaches infinity and x approaches negative infinity, we do want both of them to be a square root, so I am going to square and then square root. And please notice that I did put both the 4 and the x underneath the, I squared both of them. So when I do this, I'll have the square root of 16x squared, because we have to square the 4 and the x, over the square root of 2x squared minus 3. Now since they both have a square root, we can make one big square root sign. And now we're only concerned about the term with the highest power, so 16x squared and 2x squared. And 16x squared divided by 2x squared is going to be the 8, and we still have the square root of 8. So that's going to be our end behavior model. So then when we find the limit as x approaches infinity, again, let's look back at our original function, which was 4x over the square root of 2x squared minus 3. We know that it's the end behavior is square root of 8. We just need to figure out, is it going to be positive or negative? As I put numbers, positive numbers bigger and bigger in, the square root is always going to be a positive in the denominator, and the numerator will have 4 times a very large number, positive number, which will be positive. So this will be a positive square root 8. And then if we're finding the limit as x approaches negative infinity, again, we do want to look back at the original function. As I plug in any number into the denominator, I will always get the square root, which is going to be a positive number. And then in the numerator, when I take 4 times a negative number, I will get a negative number. So a negative divided by positive will be a negative square root of 8. And I don't remember on this one if I asked for asymptotes or not, but my asymptotes would be y equals the square root of 8 and y equals negative square root of 8. All right, problem 6, these ones are just finding the limits. Find the limit as x approaches infinity, and then find the limit as x approaches negative infinity. So we are going to see if we can figure these out. This first one, you'll notice that the one of the terms is not a polynomial term, but we can still deal with this. So the first thing that I'm going to be thinking about is if we have the sign of x, that is going to be a number always oscillating between 1 and negative 1. So it's always between negative 1 and 1. So this really will become insignificant because when you're adding or subtracting 1 from a really big number, it's not going to matter. So that part really does not count. So then we can just go to our normal end behavior process where we take the terms that have the highest power. So we're going to take negative 5x to the 4th and 3x to the 4th. If we divide those, we are going to get negative 5/3. So that's going to be our end behavior model. So the limit as x approaches infinity will be negative 5/3, and then the same thing, the limit as x approaches negative infinity, it will also approach negative 5/3. And even if I went back, if we weren't sure is one of them going to turn to a positive 5/3, if you go back into our original function, what is going to happen with that is when you plug in a big positive or negative number, again, this is always going to go back between negative 1 and 1, and then when we take something to a 4th power, it will turn positive anyway, so that will not affect our results either way. So both limits are negative 5/3. And then number 7, the limit as x approaches infinity and x approaches negative infinity again of f of x. So we are going to once again see if we can plug things in here and get answers. Since these are multiplied, I can actually find each limit separately and then multiply my answers together. In the first one, I am going to just look at if we plugged infinity, so let's just find the limit as x approaches infinity first. So the limit as I approach infinity, what I'm going to be doing on this one is 2 divided by a really, really large number is going to be 0. So that number is going to approach 0. 0 plus 1 is 1. So the limit for that first part will be 1. And then the second part, again, we can use our end behavior processes. We'll take the term with the highest power in both the numerator and denominator. 5x squared divided by x squared will be 5. So my limit for this one will be 5, and 1 times 5 is 5. And then the limit as x approaches negative infinity, nothing much is going to change. If I take 2 divided by a very large negative number, my answer will still be 0, so 0 plus 1 will still give me 1. And then in this problem, since I'm squaring both numbers, my answers will still stay. They're not going to affect anything because they'll still become positive, so my end behavior model will still be 5, so my limit going the other way will also be 5. So hopefully now you are familiar with finding horizontal asymptotes without your calculator.